So, in the last class, is mean by torsional shear. Welcome to my class. This is Kalpana, Assistant Professor in the Department of Mechanical Engineering, KG Reddy College of Engineering and Technology. Today, I am going to explain one problem which is based on torsional shear stress. What is torsional shear stress? Last class we have discussed about torsional shear stress, that is whenever the machine parts are subjected to the torque or twisting moment, therefore, then the induced stresses in the machine part will be treated as torsional shear stress. Okay. So, here torque at twisting moment is nothing but whenever a couple of forces which are acting on the member. So, therefore, it will be subjected to the torque or twisting moment, right. Now, today I have taken one unsolved problem here to solve based upon the torsional shear stress equation. See, this is my problem statement, that is a shaft which is transmitting 97.5 kilowatts at 180 rpm. Okay. So, here if the allowable shear stress in the material is 60 megapascals, therefore, tau they have given, that is that tau equals to 60 megapascal. Now, find the diameter of the shaft, we need to identify the diameter of, and if the shaft is not to exceed the twisting moment 1 degree, terms of degrees, that is 1 degree and length of 3 meters, therefore, that is equals to L equals to 3 meters. Now, take the modulus of rigidity, that C or Z, that is equals to 80 megapascals. So, in the problem statement what they have mentioned, one shaft, okay, which is transmitting the power. So, that means here the shaft, what is the work of the shaft, that is always transmitting the somewhat power from one shaft to another shaft, right. So, here it is transmitting the power. How much it is transmitting? It is transmitting the power, that is 97.5 kilowatts. Therefore, they have given that given data. So, power P equals to 97.5 kilowatts, that equals to, we can rewrite the equation, that is into 10 cube in terms of watts we can take. At 180 rpm, how much speed it is rotating? So, therefore, the shaft they have given, that is equals to 180 rpm, and they have also given the allowable shear stress. Okay. So, allowable, that much it is allowable. So, therefore, that is the allowable shear stress, that tau equals to 60 megapascals. And also the shaft is not to twist more than 1 degree. So, therefore, not to twist more than 1 degree means here they have given theta in terms of degrees, but I want to convert this theta in terms of radians, therefore, that is pi by 180 into 1. Therefore, how much we will get here? Around 0.017 something we will get the theta in terms of, okay. So, that is in terms of radians, right. So, this is given in terms of degrees. So, therefore, here and also they have given the length of the shaft, that is 3 meters. So, if you want to convert this into in terms of mm, so you can give 3 into 10 cube. Okay. So, and also they have given the modulus of rigidity, that is C equals to 80 gigapascals they have given. Actually, gigapascals when we are converting, so 80 into 10 power 9, we will write again 80 into 10 power 9 is again I want to convert in terms of the megapascals. Therefore, so this is gigapascals they have given, that I want to take in terms of Newton meters. Okay. So, I want to convert in terms of Newton mm square, therefore, 80 into 10 cube. Okay. So, Newton mm square we can write. So, therefore, this is the C value they have given in the problem. So, from this I want to know the total diameter of the shaft, right. So, how I will identify the diameter of the shaft? Based on what parameters I will take? Means I can solve the diameter based on the two parameters. One is based on the strength of the shaft. One is based on the strength of the shaft. And another one is based on the twisting moment of the, so based on the twist of the shaft. So what is the relation we need to take? We have derived the torsional shear stress equation based upon the some assumptions in the previous classes. That equation is always T by J equals to tau by R equals to C theta by L. So in one case based on the strength I will take there about these two equations. And in the other case I will take care about these two equations. So therefore I can solve the diameter of the shaft. First we will discuss strength of the shaft. Okay. So that is equals to T by J equals to tau by R. Okay. So here T by J equals to tau by R. We know that what is the value of tau? Tau is nothing but they have given that 60 megapascals. I don't know about the T, but I want to identify the T value. Based on the relation we know that power is always transmitting, that is equals to 2 pi nt by 60. Therefore from this relation T equals to, I can write 2 pi n into P divided by 60. Therefore T equals to 2 pi into n. How much given in the problem? So n equals to 180 given. So 180 into P. So that is 97.5 into 10 cube divided by 60. Therefore here I can identify the value directly. If I calculated the value, I can get the value, that is T equals to torque 5172 into 10 cube, that is in terms of torque is nothing but force into that angle distance. So there Newton mm. So this is the torque I got. So now what is mean by J? J is nothing but we all know that is polar moment of inertia. So that is pi by 32 into d power 4. So pi by 32 into d power 4, where r is nothing but d by 2. So here I want to identify the d value. Now substitute all the equations in terms of the relation. Therefore that is equals to, so T by J. So 60 megapascals they have given in the problem, that 60 megapascals divided by pi by 32 into, so J value enta avutundandi 0. If you calculate the pi by 32 value by using the calculator, so value 0.0982 into d power 4 is equals to tau by J, sorry for this. So T is nothing but 5172 into 10 cube by J, that is equals to 60, that divided by d by 2. Okay. So by solving these two equations by using the cross multiplication, we can directly get the value that d is equals to 76 mm. So this is the one way we can identify the diameter of the shaft. In other way also they have mentioned in the problem, so that is twisting moment which does not exceed the 1 degree. So if it is don't exceed the 1 degree, we have converted theta, that is in terms of, we have converted in terms of the radians. So that is the 0.017 radians. Now take the second equation based upon the twisting moment. Therefore consider that is T by J equals to C theta by L. Okay. So here we know the T, we know the J, and we know the C value, and we know the theta value, and also they have given the length of the shaft which is does not exceeds in terms of 3 meters, right. So substitute all the values here, again same 5172 into 10 cube, that divided by 0.0982 into d power 4, that is equals to C. How much given in the problem? So here 80 into 10 cube into theta 1 degrees we have converted into the radians. So therefore that into 0.017 radians divided by, so theta by L, 3 meters, in terms of mm 3000 mm. So from these two equations, when we are cross multiplying, therefore in terms of D for 4 we will get some answer. Therefore D is, after solving this, 103 mm. So this is the method to identify the diameter of the shaft, which is based on the given parameters under the torsional shear stress equation. So from this relation, T by J equals to tau by R equals to C theta by L, not only for finding the diameter of the shafts, but also we can also find by the torque T acting on the shaft, and also polar moment of inertia, and also we can identify shear tau, and also we can identify the radius of the shaft R, and also we can identify the modulus of rigidity constant, and also we can identify the twisting moment theta, and also we can identify the length of the shaft. So whatever the parameters they are asking, so based upon the given data we can identify what method is suitable, by what equation is suitable, how we have to convert the equation, whether they have given the power or whether they have given the torque, whether they have given the stresses or length, whatever it is, what are the parameters they have given, first we need to understand the problem. After that we need to write the equation T by J equals to tau by R equals to C theta by L. After that, based on the given parameters we need to identify the, so whatever they asked in the problem. So these are the model problems we can expect in the examinations. Sometimes this is the solid shaft. So how we will identify the solid shaft? If you are identifying only one diameter, so that is nothing but it is comes under the solid shaft. If you have the internal and external diameters of the shaft, compulsory we need to go for the hollow shaft equation. Therefore just we, in terms of J equals to pi by 32 into D power 4, in terms like pi by 34 into di power 4 minus d naught power 4. So when we are commoning the 4, therefore pi by 32 minus k power 4, that is the rigid this one J value we can place, and we can also find the internal and external. So these are the different model problems we can expect in the examination point of view, whatever the exams like normal regular exams or in terms of competitive. Simple problems we can solve.